So when you are considering breaking these angles up, if you're being asked to do it by hand, it's going to be angles on the unit circle, which means they're either going to end in the zeros or fives, right? Multiples of 30 degrees, multiples of 45 degrees. So if you see one that has a 5 in it, it's going to involve a multiple of 45. And so you can just pick one. 45 won't work because it needs to, if I added two things and 45 was one of them, it would still require it more than full rotation. So if I tried 135, I could see that this can be rewritten as 135 plus, and when I subtracted that, would be 330. Okay, so this is the sum I can choose when I sort of decompose that angle into these two. And this gives me my, here, the sum identity for sine is the sine of the first, the cosine of the second. Same sign, so plus. And then I switch the trig ratios, cosine of the first, sine of the second. So those would be my values. If I look on the unit circle, what they are. Here's 135 degrees. I see that my cosine is negative root 2 over 2. My sine is positive root 2 over 2. And at 330, I'm almost to a full rotation here. My cosine is root 3 over 2 positive. My sine is minus 1/2. So these are my values that I can plug in. So the sine here is root 2 over 2. The cosine here is root 3 over 2. All plus. The cosine here is negative root 2 over 2. And the sine here is minus 1/2. Minus a minus becomes a plus. And so when I calculate this, I get root 6 over 4 plus root 2 over 4. And that would be my solution. Root 6 plus root 2 all over 4. Okay, when I'm calculating this second one, the second one's a little bit easier. Again, it has a 5 in it, so I know it's going to involve a 45. So when I try to figure out what angles on the unit circle, guys, what angles on the unit circle give me 15. If I start with 45, I can subtract 30 and get my answer. Again, that's a nice, quick and easy combination. So when I set this up, it's the now it's the difference identity for sine, or the difference formula. So I take the sine of my first angle times the cosine of the second, same sign, minus. Switch the trig ratios, so cosine first times the sine of the second. And when I look on my unit circle here, 30 degrees, I get root 3 over 2 and 1/2. And then 45 degrees, I get root 2 over 2, root 2 over 2. And I can plug those in. So the sine is root 2 over 2. The cosine of 30 degrees, root 3 over 2. The sign in between is a negative. Cosine of 45 is root 2 over 2. Sine of 30 is 1/2. Calculate what I got here. Root 6 over 4 minus root 2 over 4. And that gives me my